Describe some of those emotions that you've had when you've been in this virtual world.
I like doing experiments in it, and you can fly around, and there's different things because there's no gravity, and you can turn off friction too.
I like the way how we got to move with the flying camera, and how we got to see different things in different points of view.
We've been able to.
For 6 years, we've been studying how virtual reality can help learning. And a lot of that was motivated by the fact that we think in about another 6 years, VR is going to be available wide scale throughout the society as part of kids' lives.
I can see the different balls.
This is very sensory generation. It's the television generation, the Nintendo generation. And what virtual reality does is it takes things that are abstract and symbolic, and it makes them sensory and experiential, interactive, so that kids can get a sense of why science works the way it does, and then link that back into the math and the symbols and the equations that are part of how scientists view what's going on. Well, not much is known about VR in terms of whether it helps learning, how it helps, why it helps, whether it could effectively be used in schools. So first we did a series of laboratory studies where we could control everything that was happening, and we could see which parts of VR were powerful for what kinds of learning. In Newton World, 5th and 6th grade students can learn about Newtonian dynamics and mechanics by going inside a three-dimensional world without gravity or friction. Balls of different masses move and collide along a corridor of evenly spaced columns. Learners can be inside a ball, or can beam to a different frame of reference to view what's happening from another perspective. They can see, hear, and feel forces that shape how objects move and collide. Learners can also alter a ball's mass or velocity to see how this changes what is happening. Intangible abstractions like kinetic energy are made visible and numeric to aid understanding interrelationships and to link formulas with the system's behavior. The student inside the VR equipment works in a team with other learners, collaborating to make predictions, interacting with phenomena, and reflecting on what's experienced.
Two balls.
In Maxwell World, high school students can learn about electrostatic fields. They can create a field by placing source charges, then see field lines that represent the forces and energies this generates in that region. Learners can fly around inside the field space to see what's happening from different perspectives. They can move and drop test charges to measure the intensity of forces or energies at a particular point. Students can even shift their frame of reference to ride on a test charge and be pulled around in the field space by the forces acting on it. By moving the source charges, learners can see how all other representations change in response. Students work as teams, rotating the role of being inside the VR world. They predict what an intervention will do, then experience what happens, and finally discuss how these observations differed from their expectations.
One in that charge and then one in the other charge.
And now we're out in school classrooms looking at what happens when you move into the real world, when things can't be controlled, and all the different kinds of constraints that teachers and students work under.
Can you look in the menu in your left hand?
I don't believe that you teach technology in and amongst itself. You use technology as a tool as you'd use a pencil or a book. And VR is just another tool to use. But I would have to say that it was the most instrumental part in the project and teaching of these laws of physics.
Can you fly to the camera with wings?
Despite the differences in learning styles, all the students in the class did better. They learned more. They actually doubled their knowledge according to the test that we took because of the virtual reality. These students will walk out of 6th grade with no misconceptions about these laws of physics because they've been able to test them in the ultimate environment.
I think that the VR system does help me teach. It gives the students another way to conceptualize what it is I'm talking about. I tried to pull in as many different sources and any tool that I have really to help them kind of understand what it is we're talking about.
What kind of energy does the charge in my hair have right now?
The students are very technically savvy, more so probably than a lot of their teachers are. And so when you go to implement something like this, the teacher's initial fear would be, how are the students going to learn how to do it? And the reality is that in 5 minutes they had it all figured out as far as navigating and how to use the menu. As far as actually integrating it into the curriculum, it went very well.
The virtual reality, all right. When we did the virtual reality, what did the pattern look like? Kim?
I think the virtual reality was a good way of showing that the force
What we're
field
finding
environment was
is
the
that
same.
where teachers really understand what the strengths and limits of VR are, and they work them into a larger piece of the curriculum that also involves laboratory experiences and textbooks and lectures and group discussions going on, then it can be very powerful for learning. Then it can be a new kind of complement for learning. But we also know that if VR isn't used very well, some students won't get anything much out of it. A lot of students may find that it doesn't meet their expectations. There's nothing magic about it. There's nothing that makes learning automatically better just by using VR.
One thing that was interesting for me to observe was how each situation was unique. The environment that the teacher had created in the classroom really impacted how the students used the VR system. Some teachers were really able to incorporate it into their curriculum. Others used it as a supplementary activity. So it differed based on the curriculum needs of that teacher and also the context within the classroom.
I think that I was probably most amazed by the students' enthusiasm to try something new and by their ability to pick up the concept so quickly. But I'd like to see more applications of VR outside of just science or mathematics, because I do think there's a place for that.
I think if you're a very visual person like me, it helps confirm what you're seeing in your head.
When you was talking about the field lines and things, at first I didn't quite understand what he meant, but then I noticed as far as the colors go, they change.
Because like in the computer, the virtual reality, it's much better than just looking at it in the blackboard, you know, flat. You can see like everything 3D.
It's easier to visualize a lot of different charges together instead of just two, which is usually what the teachers do on the blackboard.
I think that you get to see things in a different way, like you can see, like say a ball from underground, or you can see things moving in a different way, or collisions.
It's like hands-on, except you're not really hands-on, but you're in the VR system.
Feels like that you don't have to move any of your arm, like your legs or anything, and all you have to do is just like beam to a camera and move.
Virtual reality as a concept is a great concept, and I think that, you know, that's where we need to be heading in terms of trying to simulate things and making them more real. But in terms of getting it into the classrooms, I think maybe we need a larger platform of experiences for the students, or possibly, you know, having the machine that you can kind of switch from the virtual reality to other things instead of being a standalone VR system.
I think I would make it more of a sunglasses. And another one is the menu. I'd have just one menu. I wouldn't make it so you had to hold it.
Involve it more with like real life situations, like maybe instead of these like a grid with charges on it, show like the planets or whatever.
If you could see objects like being affected, like in 4D by the forces, it would be more helpful to see what happens to the objects.
6 years ago, when we began this virtual reality work, it was seen as exotic and kinky and expensive and kind of weird that we would want to study something that was so far over the horizon. But now that it's out in classrooms and it's much cheaper and people can see how fast the technology is moving, there's a sense in which it's very timely. It's very satisfying to be ahead of the technology for once, not to be asking as educators when something's already established, gee, could we use this in classrooms? Is this really good for learning? But to be out in front of that and to be able to answer in advance, when do we want to use this? Why would you want to use it? How can we make it effective? Under what conditions is it successful? So I think that our work has provided guidance for how to do that, but there's a lot that could be filled in the future in terms of deepening that kind of understanding.